All right, what's up, geometry? All right, so got a question about number 8, and then I think it was number 8 and 9. So we'll start off. We'll just do these two problems real quick. Okay, so you've learned the term apothem. Okay, so that's from the center of the polygon, in this case a hexagon. All right, it's that line segment that goes right to the center of one of the sides there. All right, and then you have here, from here to here, you have a radius, and from here to here, you have a radius. So basically, what you have in a regular hexagon, you have 6 equilateral triangles, and they're going to be 30, 60, 90 triangles. So remember, we learned some rules about those, right? Okay, so we learned with the 30, 60, 90 triangle. Okay, so here you have the 90-degree angle. Here you have the hypotenuse. You have the short side and the long side, right? So whatever the short side is, okay, then the long side is going to be whatever the short side is times the square root of 3. And the hypotenuse is going to be 2 times the length of the short side. Okay? So let's look at this. So this one, it gives us a perimeter of 48 inches. So we know that the measurement all the way around is 48 inches. Well, in a regular hexagon, each side is equal. So just take 48 divided by 6, and you'll figure out that this entire side right here, just like the other sides, is 8 inches. Okay, so that means that just the short side of the triangle then is 4. So this from here to here is 4. So that means that this is 4 times the square root of 3 in its length. And that means that this is 2 times the length of this, which means this is 8. Okay, but what we need is the length of the apothem, because the formula that you have, okay, the formula that you have is, so for the area of a regular polygon, it's going to be the apothem is, or I'm sorry, the area, the formula for area is, so area equals 1/2, okay, the apothem times the perimeter. Okay, so we have all that information here. Okay, so we said that the apothem was 4 times the square root of 3. We already know that the perimeter is 48, so we're just going to plug it in. So it's going to be area equals 1/2 times 4 times the square root of 3, which is the apothem, times 48. Okay, so just go from left to right. So 1/2 times 4, this is going to give you 2 times the square root of 3 times 48. Just multiply your coefficients, the coefficient of 2 times 48, and you're going to get 96 times the square root of 3. So the area equals 96 times the square root of 3. Okay, so there's that's number 8. All right, now number 9, a little bit different. Okay, so they give us the apothem here, but we're still going to use this 30, 60, 90 triangle. Okay, and they tell us that the apothem, which here's a radius and here's a radius, so the apothem actually goes right here. And they tell us that the apothem is 2 times the square root of 3. Okay? All right, well, again, we need to figure out, there's only two things we need, right, to find the area. We need the apothem and we need the perimeter. That's what we don't have, but we're about to get it. Okay, so check it out. Remember that the long side of a 30, 60, 90 triangle, okay, is the square root of 3 times whatever this is. Well, okay, we have the square root of 3 times what? Well, 2. So that means that this is 2. Okay, and then this would be 4, because the hypotenuse is twice the length of the short side. The long side is the short side times the square root of 3. Well, again, we have the square root of 3 times what? Well, 2, okay? Well, that means that this entire side then is 4. Which means that this is 4, and this is 4, and this is 4, and this is 4, and this is 4. So 4 times 6 is 24. Okay, so we have everything we need. The perimeter is 24. So we're going to take 1/2 times 2 times the square root of 3 times 24. Okay, well, 1/2 times 2 is 1, so we have basically the square root of 3. So the square root of 3, that's the same thing as 1 times the square root of 3 times 24. So that's your final answer. 24 times the square root of 3. Okay, hope this helps. You guys take care, okay?